Welcome to this tutorial on simplifying polynomials using algebra tiles. So a quick introduction to algebra tiles. There are three sizes or shapes of algebra tiles. They come in both blue and red. So blue represents positive and red represents negative. And the names of the tiles are representative of the area of them. So the large square is the x squared tile, and it would be a square with side lengths x and x. So x times x gives its area of x squared. The rectangle has the same length as the x squared, but it has a width of 1, and so its area is just x. And then the small square is just 1 by 1, and so it represents 1. Just a little bit of terminology before we begin. Polynomial means many numbers. And if we're talking about specific types of polynomials, there are three that we would not just use the word polynomial for. So one is if we have one term or number. So a term is anything that is separated by an addition or a subtraction. And so if we have only one term, we call it a monomial, and I like to think of the word monocle. If we have a binomial, then that's two terms. So just like this first example here, we have a 3x and then a minus 5, so there's two terms there. And for a trinomial, that would be three terms. So our second example here, x squared minus x plus 1, 1, 2, 3 terms. Okay, so representing these using algebra tiles, if we have 3x minus 5, so 3x means we need 3 of the x tiles. And then if we have minus 5, then we require 5 negative 1 tiles. And so that is 3x minus 5 using algebra tiles. For our second example, similarly, we've got 1x squared tile. So we bring that in there. We have 1 negative x. And then we have plus 1 at the end. And so that gives us x squared minus x plus 1. So now we want to use these algebra tiles to not just represent these polynomials, but simplify them together. So we've got two examples on this next page here. The first one is actually the same two polynomials that we already looked at, but now we're adding them together. So when we're simplifying using algebra tiles, we can actually ignore the plus sign, okay, when it is plus. We'll take a look at subtraction in a minute. And what we're just going to do is compare the tiles that are the same size. So we just want to count how many of them there are in total. But the interesting thing is that when we have positives and negatives, if I have 1 minus 1, well, that's just 0. So if we have a blue tile and a red tile that are the same shape or same size, then they cancel each other and disappear. So we also have a positive x and a negative x that are going to cancel out as well in this example. And so that leaves us with 1x squared, 2x minus 4. In the second example here, what gets a little bit trickier is that we have a subtraction. So we need to think about what happens when I subtract something. So if I'm subtracting 2x squared, that's the same thing as adding negative 2x squared. So I'm going to delete the subtraction, but in order to do that, what needs to happen is that these two positive x squareds need to turn into negative x squareds. And similarly, the negative x's will become positive x's, and the negative ones will become positive ones. And so now I've turned this subtraction into an addition, and I can cancel out the tiles that are the same size but opposite sign. So a positive x squared and a negative x squared are going to cancel out. I have two positive x's that can cancel out with the two negative x's. And then I have a positive 1 and a negative 1 that cancel out. And so I'm left with negative x squared plus positive 1x plus 2. So I hope that you found this helpful in terms of using algebra tiles to simplify polynomials, and happy mathing!